Good morning. Suppose we have a circuit like this and we want to calculate all the currents in the branches. First thing to do, I think, is to calculate the equivalent impedance of this circuit. Before that, we have to do some transformation. The transformation is star delta transformation and delta star transformations. I will remind you about the equations. If you have to transform a delta into R1, R2, R3, if you want to transform it into a star, I will give you the equations now. This one is R1 prime, this one is R2 prime, and this is R3 prime. So we can calculate R1 prime is equal to R1. Where is R1 prime? Here, R1 prime is R2 times R3 over the sum of the three resistors. Okay, R2 prime will be R1 times R3 over the sum of the R's, and R3 prime is R1 times R2 over the sum of the R's. Now, if we have to calculate the delta equivalent of a star, then the equations will be as follows. R1 will be equal, we divide it by R1 prime. R2 will be divided by R2 prime. R3 will be divided by R3 prime. And on top will be R1, R2 prime plus R2 prime, R3 prime plus R3 prime, R1 prime. Same thing here and same thing here. So let's start to do the first transformation. Here we have a star and we have the values here, and we transform it into an equivalent star. So it means that if R1 is equal to 30, R2 is equal to 90, and R3 is equal to 60. So we calculated the equivalent resistances of this. R3 prime is 15 ohms, R1 prime is 30, and R2 prime is 10. Now, we add this to this one. I called it R4 prime. So it means R4, which is equal to 5, plus 15 will give 20, and 10 plus 30 will give 40, and 6 plus 10 will be 16. So we do another transformation, which is star to delta, that is here, and we calculated these values as R5 2 prime, R6 2 prime, R4 2 prime, which is 88, 110, and 44 here. Now we can calculate the equivalent resistance, and later we can calculate the currents. First of all, let's calculate the equivalent resistance. Equivalent resistance is R9 plus R10, which is equal to 17 plus 50, 17 plus 50, plus we have R7, which is in parallel with R6 2 prime, plus R4 2 prime, which is in parallel with R8, and these two are in parallel again. I'll do it closer. R7 is in parallel with R6 2 prime, are in series with these two, are 8 in parallel with A, are 4 2 prime, and then these two are in parallel with R 5 2 prime, and these are in series with this. So this one will give us 140 in parallel with 110, will give us 88 ohms, plus this is 88 and 88 will give us 44. The sum of the two will give us 132, which is in parallel with 44, will give us 33. We have a good value here, 33. 33 ohms plus 67 will give us an equivalent resistance of 100 ohms. And from here we can calculate this current, the main current, which is equal to voltage. Main voltage is equal to 100 volts. So the main current is I will calculate it here. I is equal to V over RE, and this is equal to 100 over 100. It's 1 amp. Now we can calculate by the current divider, current I prime and R2 prime. R prime is the equivalent resistance of this 4, which we calculated as 33, I think. 33. These 4 are 33 ohms, and this one is 44. Is it? No. It's 132. And these are 33. 132 ohms. Okay. So we calculate I1 prime is R5 2 prime over this, how would I call it? Okay, this value of 132, equivalent resistance of this 4 plus R5 2 prime times main current, which is 1. Here it's 132 over 132 plus R5 2 prime times 1. This will give us a current of well, where is my calculator? I will calculate it because 132 plus 44 1 over times 132. This will give us 0.75 amps, and this will give us the rest 0.25 amps. So it means here it's 250 milliamp flowing here, and here we have 0.75 amp. Okay, once we have calculated this by current divider, we can calculate E7 and I8, which has we need these two currents. I7 will be R6 2 prime over R7 plus R6 2 prime times I prime, and this one 8 will be R4 2 prime over R8 plus R4 2 prime times this current, which is 250. So it means 110 over 107, which is 440 plus 110 times 250 milliamp. Okay, 440 plus 110, 1 over times 110 times 250. So it means I7 is 50 milliamp and here it's 200 milliamp. So I have calculated I7, it's 50 milliamp, I8 is 200 milliamp. We can calculate now here from this circuit. We can calculate, I write down the result. I7 is 50 milliamp, I8 is 200 milliamp. The main current is okay. Let's continue. If I7 and I8 are known, so it means 250, so it means that is it 200? 8? No, there is a problem. It's not 200. Here I have to calculate it. It's not 200. R4 88 times this one, 250, 88 over 88 plus 88. This is 125 milliamps. Okay, 125. I will write down again. 125 milliamp. And from this we can calculate I5. I5 is equal to I7, 50 it means here flows it's I8 minus A7. It means here will flow 125 minus 50. It will be 125 minus 50 is 75 milliamp. Here flows 75 milli. Here will flow I4, which is 1 minus 50. Here I4 is equal to 1 minus 50, 0.95 amps. Okay, we have calculated this. This current is I4 minus I5. It means 0.95 minus 0.75. This current I6, it's 0.875. Now we have to calculate the current that flows. Here the current that flows here is I4, and the current that flows here is I4 minus I5, and the drop here in these two resistances divided by I1 will give us the current I1, which is VR1 over R1. You can calculate it. So it's R3 primes times this current, which is 0.95 plus the drop here, which is 10 times 0.875 divided by 30 will give us a current of I1. Did I calculate it? I1. You see, I have to do it again. Okay, 15 times 0.95. This is 23 volts over 30. 23 volts divided by 30, it's 0.766. 0.766 amps that flows in R1. We are left with I3, I think, to calculate I2 and I3. I2 will be I4 minus I1, 0.95 minus 0.7666, it's 0.184. We are using Kirchhoff's current law, so I2 is equal to I4 minus I1, and now I3 will be equal to I2 minus I5. Here the current that flows is 0.84 minus 0.75, and this is, if I'm not mistaken, 0.109 amps. We have calculated all the currents using, of course, the current divider, Kirchhoff's current law. We calculated the equivalent resistance. We calculated the main current, so the main current is 100 over 100, and later by current divider we calculated I prime and I2 prime. From this I prime current divider we calculated I7. From the current divider we calculated I8, and later from I minus I7 is I4, I7 minus I5 is I8, I4 times this resistance plus the drop in this resistance divided by R1 will give us this current I1, and now I4 minus I1 will give us I2, and I2 minus I5 will give us I3. And we finished, we calculated all the currents. And thank you very much.